open belt drive and the cross belt drive. Okay. Now let me discuss a few things about the some definitions I wanted you to understand. The creep in the belt. What is the meaning of creep in the belt? As I told you, continuously the belt will be rotating on the two pulleys. While it is carrying the driving pulley, what happens? A tight side and the slack side will be created. The tight slide and the slack side. You can see in this small observation you can make. You can look here. This is, you say, let us say this is the driving pulley and this is the driven pulley. The driving pulley is rotating in this direction. That means to say it is the belt will be giving the enough support and take the support and rotate on this. So definitely this particular side will become a tight slide and this slide will become a slack side. Always the T1 will be a tight side, the tension will be more, and a T2 will be a tension created in the slack side, it will be lesser. Okay, and you can see that the portion of the belt which is in the tight side, once it go to this side, it will be in the slack side. So due to this alternate positioning of the belt in the tightened and loosened position, what happens? The belt will be loosened, and due to this, what happens? The length of the belt will be increased. So this is called creep in the belt. The creep in the belt is due to tensions created in the tight side and the slack side. While the belt is running over the pulleys, what happens? The portion of the belt which was in the T1 side will be going to the T2 side. The portion of the belt which was in the T2 side will come to the T1 side. So due to this alternatively tightening and loosening of the belt, what happens? The length of the belt will be increased. This kind of effect is called the creep in the belt. This is called creep in the belt. It is not advisable to have it, so, but naturally it will happen. After using for many days, there will be creep in the belt. Then what happens if it is a flat belt drive? They have to cut down little portion and again re-rivet it once again. If it is a V belt or a timer belt or ribber belt, we have to throw it and replace it by other one. It is not possible to repair it in case of other three. Okay. And what is the meaning of a slip? The belt slip. Already we understood what is the meaning of creep. The tension T1 and T2 will be there. Always the T1 will be greater than T2. So due to this, what happens for many rotations, continuously rotating. So due to this creep, what happens? The belt become loosened. As I told you, this total pulley and the belt system will be working based on the enough friction between them. So once the belt is loosened, what happens? Enough friction will not be there. So without carrying the driving pulley, simply the belt will be running over the driving pulley. So it will be driving, but not proportionally. So due to this, what happens? There will be a slip in the belt. The slip in the belt is due to the many reasons. As I told you, continuously it will be running, and once what happens? The pulley and the inside surface of the belt will become smoother. That may be one reason. And due to this, what happens? Due to smoothness, the coefficient of friction will become lesser. There will not be enough creep. And due to the creep, the length in the belt will be increased. And due to this, a larger difference in the tensions will happen in the tension and the slack side. These are the 4 reasons due to which there will be a slip in the belt. So please remember, the creep in the belt and the slip in the belt, these 2 are very, very important to understand for the understanding of the belts. Now, let me try to have a slight understanding about the velocity ratio between the belt drives. Let us go for the gear drives. In the gear drives, if the gear A is a driver, gear B is a driven, what happens? The velocity ratio will be equal to the speed of the driven pulley to the speed of the driving pulley. That will be equal to T1 by T2. That will be equal to T1 by T2 earlier. So N2 by N1 will be equal to D1 by D2, that is equal to T1 by T2 in case of gear drives. In case of the belt drives, you can see that how it is. It is also similar. It is also similar. Now let me take the consideration of the open belt drive or a cross belt drive. There is no problem. Only the direction will be changing. Okay, let us say D1 is the diameter of the driver pulley. D1 is the diameter of the driver pulley and D2 is the diameter of the driven pulley. Let the C be the center distance of this and let N1 be the speed of the driver pulley and N2 be the speed of the driven pulley. Okay, driven pulley. Now the diameter of the driver pulley, diameter of the driven pulley and the speed of the driver pulley and speed of the driven pulley we know. Now in a minute, what would be the length of the belt which will be passing over the driver pulley will be pi d1 n1. Pi dn is the length of the belt which will be passing over the pulley in a minute. And let pi d2 n2 will be the length of the belt which will be passing over the driven pulley. Then what happens? The length of the belt which is passes over the driver pulley must be equal to the length of the belt which will be passing over the driven pulley. That will be pi d1 and n1 equal to pi d2 n2. In other way we can say n2 by n1 is equal to d1 by d2. You know that already. In the gear drives you already know that n2 by n1 will be equal to d1 by d2. That will be equal to t1 by t2 in case of gear drives. In case of this belt drives, it is N2 by N1 will be equal to D1 by D2. Similar. And whenever you are going to consider the thickness of the belt also, then along with this D1, add the T all. Along with this D2, you add T. So N2 by N1 will be equal to D1 plus T divided by D2 plus T. In the problem, for example, they'll be giving us an open belt drive consists of a flat belt. The diameter of the driver pulley is 600 mm. The diameter of the driven pulley is to be found out. The speed of the driver pulley is 600 rpm and the thickness of the belt is 5 mm. Find the speed at which the driven pulley is rotating and in which direction and what would be the diameter of it. We can able to easily find out. We can able to find out the velocity ratio. We can able to find out the unknown thickness or unknown diameter of the pulleys. It is possible. So this is about the velocity ratio of the belts. Okay. So any doubts are there, you can ask me about the velocity ratio. About the velocity ratio, any doubts are there? They'll not be giving you what would be the velocity ratio of the V belt drive, timer belt drive, or a ribbed belt drive, cross belt drive. They'll not be giving you. Only the velocity ratio. That's all. Velocity ratio will be equal to the speed of the driven pulley to the speed of the driver pulley is this ratio is called as the velocity ratio. That will be equal to diameter of the driver pulley to the diameter of the driven pulley. That is N2 by N1 will be equal to D1 by D2. That's all. If you are going to take the thickness into account, then N2 by N1 will be equal to D1 plus T divided by D2 plus T. This will be the velocity ratio. On this, we will be getting one problem. In the examination also, we can expect one problem. Okay, for the test also will be given one problem. Now let me see, already we have seen the flat belt drive. Under them the two different arrangements which necessarily we are going to do whenever we need to rotate the pulleys in the defined directions, or the center distance between them is slightly different. So based on this, we are going to select the cross belt drives or open belt drives. Now let me come to the V belt drive. V belt drive, you can see that the pulleys, again let me go back to this. You can see here there will be V grooves will be there in both the pulleys. This is a driver pulley, this will be the driven pulley, and on these grooves these V belts will be running. The V belts will be from 3 to 5, 6, 7 even. Okay, whenever more torque to be transmitted, the capacity to be very high, just like in the presses and all, what happens, we are going to use the V belts up to 4 or 5. No one will be using 1 or 2. Okay, a minimum of 3, maximum whatever it is. Okay, this is the arrangement of the V belt drive. Now let me look into the conditions. You can see here, this is a pulley I have written. This is a pulley arrangement, and on this the cross section of the V belt has shown, and the V belt will be having this particular V groove is made, and due to this narrow section, what happens, the available cross section will be giving maximum gripping surface, so that there will be maximum friction between the pulley and the belt, so that with the initial torque maximum even it can able to run. One thing. And the cross section of this belt will be in the trapezoidal section, the trapezoid section, and the bottom portion of this is not touching the pulley. If it is touching here, what happens, there will be interlocking of the belt with the pulleys, so that it will be avoided. It will be avoided. And how the V belt will be made? Of course, the fabrication process of the V belt is not there with our syllabus, and one has to understand what is this. See, it will be having 3 different layers. One is the outer layer. It is called the fabric and the rubber cover. A fabric and rubber cover will be there, and on this there will be cord, and below this there will be a fabric. All this will be fabricated in such a way that it will be taking a proper shape, molded in a proper way, so it can able to create the maximum tension. Which can able to create the maximum tension. And when you are going to use this V belts, the V belt drives, please understand, the flat belt drives, you have seen that floor mill. In the floor mill, we will be using the flat belt drives. The V belt drives, one important thing is that whenever the initial maximum torque is there,